Hi, I'm Dr. Rod Shaw of Math Plus Academy, and I'm proud to be a part of the Global Math Project. It is a nonprofit organization dedicated to bringing joyful mathematics to students in classrooms around the globe. And every year in October, we celebrate Global Math Week, which starts on October 10th. Over the last several years, over 6 million students have participated in Global Math Week around the world. And what they've done is explored James Tanton's exploding dots, which you can learn more about here at globalmathproject.org/exploding dots. Exploding dots is an amazing model that explains so much of K-12 mathematics. It's a visual representation of place value. It will help you explore different bases, arithmetics, algorithms, procedures, algebra. There's so much cool stuff in there, and there are even questions that mathematicians don't know the answers to yet. And some of that is what we're going to explore in this math treat. Now, you can do this math treat without ever having seen exploding dots before. But I do recommend you check out globalmathproject.org/exploding dots and view the videos of the first two explorations. It'll give you a really good baseline and help you go deeper and further into the math that we're going to explore today. In this math treat, we'll explore this weird and strange machine called a 3-to-2 machine. And all it is a series of boxes in which I place dots in this rightmost box. Now here I've drawn 4, but you can imagine these boxes going forever to the left, hence the little dots there. So if we need more boxes, we can add them. All we're going to do is place dots in there, follow this rule, and then see what results. And we're going to imagine that whatever we get after we put the dots in is kind of a secret code for the number of dots that were placed in the machine. So let me explain what that means. Let's start by putting 1 dot into the machine. So there you go. There's 1 dot. Now, I check to see, will there be any explosions? No, there won't, because I don't have 3 dots in a box anywhere. And then I just read out the code for 1, which is all empty boxes, and then a 1. And I'll ignore all these zeros. So the code for 1 is simply 1. Okay, not super exciting. Let's put in another dot. Wow. Okay, 2 dots, no explosions. What's the code for 2? All zeros, 2. All right, let's see if we can amp this up. Let's put a 3rd dot in the machine. Now we're exploring 3. Okay, now we're going to have an explosion. 3 dots in this box. Kapow! These 3 dots go away, and they are replaced with 2 dots in the box to the left. So that is what happens. Now, no more explosions. I read out the code. All zeros, 2, 0. So the code for 3 is 2, 0. Okay? Not 20, 2, 0. Let's add another dot. Let's look at 4. We'll put another dot in. That's my 4th dot into the machine. And no more explosions are going to happen. The code for 4 is 2, 1. Let's put a 5th dot in. No explosions are going to happen. The code for 5 is 2, 2. Let's put a 6th dot in. All right, now we have some fun here. We're going to get an explosion in this box. These 3 will explode and turn into 2 of these. And we keep looking for explosions. So now there's more than 3 in here. 3 of them will explode, 1, 2, 3, and create 2 dots in the box to the left. Now I'm done with my explosions. The code for 6 is 2, 1, 0. Let's add a 7th dot, 7. Okay, no more explosions. 2, 1, 1. You can probably imagine what will happen with 8. 2, 1, 2. And 9 gets really interesting. Maybe pause for a second, see if you can think about what's going to happen when I get 9. How many explosions are we going to have? All right, let's see. Put the 9th dot in. We're definitely getting an explosion in the rightmost box. These 3 explode. Kapow. We get 2 new dots. Oh, look, 3 in there. Kapow. We get 2 new dots. Oh my goodness, 3 more in here. Kapow again. 2 new dots, and now we're done. 2, 1, 0, 0. What I'd like you to do now is keep going with this machine. Put some more dots in, write the codes for 10 and 11, maybe go up to 20 or 30, and then step back and look at your codes and think about what do you notice and what are some interesting questions we can ask. So right off the bat, I notice that all the codes only have 0s, 1s, and 2s. Is that always true? If so, why is it always true? Another thing I notice is that 1 and 2 had 1-digit codes, 3, 4, and 5 had 2-digit codes, 6, 7, and 8 had 3-digit codes, 9 has a 4-digit code. What's the first number where I get a 5-digit code? How many 4-digit code numbers will there be? Who knows? Can you create some sort of, can you figure out how that pattern works? When do I get a new digit? Another thing I notice is for the codes 3, 4, and 5, they're all 2 digits. They all start with a 2. Why are there no 2-digit codes that start with 1? What would 1, 0 look like, or 1, 1, or 1, 2? Those don't even exist. What do those represent? And why aren't they here? Same thing with 3-digit codes. There are some missing 3-digit codes. As I look at it some more, I'm noticing, with the exception of 1, these all start with 2. Do all the codes start with 2? Forever? I don't know. Explore. Let me know what you find out. Another question is, if I gave you a set of dots in here, could you figure out how many did we start with? What's the number that goes with a particular code? Can you work backwards? So for example, here, I know these 2 dots, because of the way the machine works, they must have come from 3 dots in this box. So then I could imagine kind of working backwards to figure out how many dots were there at the beginning. These 2 came from 3. Then there would be 4 in here, which is 2 groups of 2. So each of those groups of 2 came from 3 in here. That would put 6 in there. And then I could figure this out. See if you can figure out how the machine works in reverse. Given a code, can you find the number? In base 10, we have divisibility rules. For example, we know a number is divisible by 9 if you add up all the digits and they add up to a multiple of 9. Do those kinds of rules exist here? Can you tell when a number is divisible by 9 just by looking at the code? Not by figuring out what it represents, but if I gave you a code, could you tell if it was a number divisible by 9, or divisible by 3, or divisible by 2, or by 5? Do these rules exist in this funky number code system? And if you've explored exploding dots and you understand that these machines relate to different bases like base 2 and base 10 and other things like that, what base is this? What base is the 3 to 2 machine? What does that even mean? And so you can continue to explore. What's really cool about this math treat is that a lot of these questions are open questions that mathematicians have yet to solve. I think that's really, really cool. So remember, you are exploring James Tanton's Exploding Dots. You can learn more at globalmathproject.org/exploding dots to get the details. I've asked you a lot of interesting questions about the 3-2 machine. As always, I just want you to have fun playing with the math.